Okay, let's go ahead and talk. This is just a review for your core test. One thing that we score low on, and I'm not very good at teaching, I guess, would be molecule shapes and how the shapes affect the properties of the substance, like its melting point, its boiling point, and its polarity. So just pause this if you want and draw these three things, or as I teach them, just kind of pay attention and you should be fine. First off, we're going to talk about water. Everyone in this class better know that water is H2O. And we've drawn water a lot, and water is an oxygen and two hydrogens. Well, when they align themselves, they don't align themselves in a straight line. They align themselves in this formation, and we call this shape bent. Now, the reason it's bent is because there's some electron pairs up here, and they occupy space, and they push those those clouds where the hydrogen are attached farther down. So you need to tie water to bent. All right? It might give you this structure, it might just give you the formula, but you need to know that it's bent. And then you need to know that in general, bent substances, and especially water, are polar. All right? Polar means that they don't share their electrons equally. Okay? So water is bent and polar. Now, part of being polar, that means that it will have like a medium, I should say, melting point and boiling point. So what medium means, it's not like in the high, like hundreds or thousands, like a 2,000 degree boiling point or like an 800. Water boils at 100 degrees Celsius and it freezes at 0. That's a little bit higher than other things and quite a bit higher than things that are considered nonpolar. Now, there's more than one reason why water also has hydrogen bonding, but for right now, just know water is bent and polar. Now, moving to the next one, we have ammonia. Ammonia has the chemical formula of NH3. And ammonia looks like one N with three H's forced down below it. And once again, that's because there's an electron pair up here that's exerting a force, forcing them down. Now, this has a name. It's called Trigonal Pyramidal. Trigonal Pyramidal means it has three things attached to the central atom, but they're forced down into the shape of a pyramid because of this electron pair up here. Now, in general, once again, and there's exceptions to all of these things, but in general, things that are trigonal pyramidal are also polar, which means it would have medium melting and boiling points. Now, ammonia actually has a much lower temperature at which it boils and melts because it does not have hydrogen bonding. But as far as its shape is concerned, you need to know that ammonia, NH3, is this structure, trigonal pyramidal, and it's polar. Now, the last one we're going to talk about is called methane. And this is just natural gas, essentially. It's a central carbon bonded to 4 hydrogens. This structure is called tetrahedral. Like Tetris, every shape you use was made out of 4 things. Tetra means 4. Hedral just means kind of in a pyramidal shape. So these, in general, once again, and there's lots of exceptions to these, but in general, things that are tetrahedral are nonpolar. That's because when we look at something that's tetrahedral, and we're talking about sharing of electrons, there is a pull, but any pull of an electron from one side to the other is canceled out by the other one canceling it out. So there's no net pull. Now, since these are nonpolar, that means there's no real pull of attraction in one to another. So these have really, really low, let's put very low melting point and boiling point. And you can think about that. Natural gas comes out of our spigots as a gas. Water comes out as a liquid. And ammonia, it's a little bit tricky because what you think is ammonia isn't necessarily just pure ammonia. That's ammonia in water. So we have what we're going to consider in this case a high to medium for water, melting and boiling point, a medium low, and a very low. So that should help you with shapes and kind of their properties.